he could be the next Bill Nye the Science Guy. What do you guys think? There's a tremendous amount of STEM activity going on just down the road from our studio at the new Broughal Middle School. The students there have a portal to the stars. They get to visit the stars in the school's planetarium. Students follow their senses to the Science of Food lab, where they do hands-on experiments and prepare recipes, often with ingredients grown in the school's very own greenhouse. Broughal students use cookware in kitchens and probeware in science. Tempo and Depth's Grover Silcox gives us a front row seat to see Broughall's formula for getting kids turned on to science, technology, engineering, and math.
The Bethlehem Area School District designed the new Broughal Middle School building with the idea of encouraging and facilitating student achievement in STEM: science, technology, engineering, and math.
We had a lot to say on what we would like to have in the school. For example, our planetarium, our Science of Foods lab, our greenhouse, and just the overall setup of the labs that we have at Broughal.
The new school, built near where the old school stood in South Bethlehem, opened its doors 3 years ago. As a Title I school, Broughal received grant money to help fund its leading-edge facilities, such as the planetarium.
You should notice the shadows of the moons going on Jupiter.
The school's planetarium gives students a window to the universe.
It's amazing because unlike the old planetariums where you can only see the stars, you can see stars, planets, you can even land on the planets. And, you know, I can type something in and bring it up, constellations, anything in space you can basically see in the planetarium.
It kind of feels like the real 3D as opposed to movie theater 3D. It's pretty cool.
It's very cool to see the stars and the planets up close and to see what they actually look like.
Serena Calario uses a program called Starry Night that enables her to create and project vivid lessons on the planetarium's dome. The students have a similar version on their laptops.
I have control of the program Starry Night on the dome, but they get to control their own program when they use it on the laptops to see their own angles of the planets and land on the planets and do what they want to do with the planets.
Even here, where the stars entertain, there's hands-on activities.
It's more of an inquiry-based model where the kids are learning on their own and discovering on their own as a teacher, as a guide. And that's not a traditional classroom.
The Science of Foods lab, with 5 kitchens, also skews the traditional classroom.
Tell the kids that the first word there is science, not foods, because they all come in wanting to cook something. We do cook, but we also put the science into it. We talk about agriculture, biology, chemistry, engineering.
On this day, these 7th graders learn about corn science.
I think some of the products that corn's in will wow them.
Carpet stuff, okay. What's
soap and cream.
Okay.
Toothpaste,
powder,
baking powder,
what else?
makeup, crayons, book, cups.
Here we have
gum, ketchup, candy canes, soda, cake mix, fluff, cereal.
Okay, that's a pretty wide variety of stuff, isn't it?
Yes.
Some solids were books, crayons, even like the powder that you use to clean carpets.
Later, these students will plant corn and other crops in the school's greenhouse. But right now, it's off to the kitchen to turn corn into plastic.
They're going to learn to make corn-based plastic, which they'll make in the microwaves using cornstarch. And we'll talk about the relationship of using a food product for a non-edible product. What are the benefits? What are the drawbacks?
Teacher Karen Wilmore guides them through measuring the ingredients to microwaving the contents and the final results.
It's just like awesomeness.
We made plastic today, and the weird thing about it is that it was first a liquid and then it turned into a solid with heat.
Science teacher Matt Lyons and his class of 6th graders also experiment with temperature changes using probeware and observation.
Today we'll be using a temperature probe to check out an energy release and an energy gain.
The students have pre-measured the ingredients for their experiment. 10 grams of calcium chloride, or salt, and 10 grams of baking soda. They're going to be mixing that with water and a dye as an indicator.
A lot of the textbooks are pretty complicated, and sometimes you can bring it more to their level by doing simple hands-on things that also get the wow.
Matt encourages the class to observe any changes.
Make sure the probe stays wet. Add your baking soda.
Matt moves the kids along like a play-by-play announcer, but he's asking questions each step of the way.
Bubbling, what's that telling you? What's it doing?
It's getting colder.
It's getting colder as well. What else do you see? What else do you observe?
The color. Oh, because it's chemical change.
You got it, Lavashka. Okay, and you just told me 3 different signs. It's making a gas. That's a new substance. It changes color, right? And also because you have a change in temperature.
The students see through their own observations and the digital readout how the liquid goes through chemical changes, becoming warmer, then colder, and changing colors.
I thought that there was going to be like a little explosion.
The kids get really excited. Anytime that they expect one result and another comes out, it starts them asking the questions of why, and then we really get to the deeper levels of understanding.
And that can lead to a deeper level of interest and perhaps even a career as a food scientist, astronomer, or even a science teacher. For these students, the possibilities are limitless. For Tempo in Depth, I'm Grover Silcox reporting.